This is exercise 4.8, question 19. In this question, we are told that we have a quadrilateral PQRS. We're also told that PQ is perpendicular to QR, hence we've got a right angle there at Q. And we're told that SR is perpendicular to QR, hence we have a right angle there at R. First part of the question, part A, we have to prove that PR squared, which is there, PR squared, minus QS squared is equal to PQ squared minus RS squared. Now automatically we can see that there is no line PR drawn and no line QS drawn, so we should put those in on our diagram first. So we've constructed PR and we've constructed QS. So we can come up with expressions. We can see that we need to prove that PR squared minus QS squared equals PQ squared minus RS squared. So we need to come up with an expression for PR squared. We can see that it's in triangle PRQ, so we can just say that PR squared plus PQ squared equals QR squared. So PR squared equals PQ squared plus QR squared. We can come up with an expression for QS squared in triangle QSR. So we can say that QS squared equals RS squared plus QR squared. And now we can fix up the left-hand side of this equation, which is to prove that, to come up with an expression for PR squared minus QS squared. So we've got PR squared minus QS squared. We just substitute in from these first two lines. So PR squared is PQ squared minus QR squared minus, now we need to take away QS squared, so we need to put brackets for what the expression for QS squared is because it's more than one thing. So minus RS squared plus QR squared. We then need to open these brackets, so remove the brackets. So we've got PQ squared plus QR squared minus RS squared, but then it's also minus QR squared. We can see that the QR squareds cancel, and hence we're left with PQ squared minus RS squared, which is what we were required to prove. Now in part B of this question, we're asked to hence prove that PS squared, so PS squared minus QR squared, so minus QR squared, is equal to PQ minus RS. Now, all squared. Now, you can see that PQ minus RS is in a bracket. Now, RS it looks like QRS. If I put a point over here, T, I could actually draw up a rectangle if I put the point T here. So what we're going to do, we're going to construct a rectangle there, and it's going to be called QRST. So we're going to construct ST parallel to QR and perpendicular to PQ such that QRST is a rectangle. Now the reason that we're constructing ST is that we look at the question, we have to prove that PS squared minus QR squared. So we need an expression for PS squared, and we really can't come up with one using Pythagoras' theorem unless we draw ST at right angles to PT. So we've done that, and if it's at right angles to PT, and we've got a right angle there, these are also going to be parallel lines. So ST will be parallel to QR because we can see here that these corresponding angles at T and Q are equal. So therefore QRST is a rectangle. Now we can also look at the question here, PQ minus RS. So we've got the length PQ minus the length RS really is the same as saying the length PQ minus QT, because SR equals QT. So we're going to use that in our question as well. So we've got a few things that we need to think about. We need to come up with an expression for PS squared. We know that, there's a few things. We know that QR equals ST. We know that SR equals QT. So we're going to use all of those facts in this proof. So let's start with just an expression here for PT, because I want to come up with this expression PQ minus RS. So we know that PT is PQ minus QT. So we've got that there on the first line. that PT equals PQ minus QT. But if I look up at the question, I want an expression for PQ minus RS. So we can see that QT is the same as RS. So on the next line, we say, well, PT equals PQ minus RS because QT is equal to SR because they are opposite sides of that rectangle. So therefore, we're trying to come up with this expression PQ minus RS all squared. So if PT is PQ minus RS, then PT squared will be all of that expression squared. So you must put it in brackets. So it's PQ minus RS in brackets all squared, because what is in brackets is what PT is, and we just want PT squared. So we leave it like that, we don't expand it. Now, we want again to come up with this expression for PS squared minus QR squared. So we want PS squared minus QR squared. Now they don't seem to be in the same triangle, to use Pythagoras' theorem, but QR is actually the same length as ST. So if we want to say PS squared minus QR squared, it's really the same as saying PS squared minus ST squared, because ST and QR are the same lengths. So what we're going to do, we're going to start off in this triangle PTS. So in triangle PTS, we know that PT squared is PS squared minus ST squared. Now I've chosen to do it like that because I'm trying to come up with this expression PS squared minus QR squared. So I'm doing PS squared minus ST squared first, and then I'm going to replace the ST with the QR. So on the next line I can say, well, PT squared is PS squared minus QR squared because ST equals QR and that they are opposite sides of a rectangle. Hence, I have an expression here, like we're trying to come up with PS squared minus QR squared. I've got that expression there. So PS squared minus QR squared we know is PT squared. We've also got an expression for this right-hand side, which is PQ minus RS all squared. We can see we've got that expression here. PQ minus RS all squared is also equal to PT squared. And because both of those are equal to PT squared, then they are both equal to each other. So we can say, therefore, PS squared minus QR squared is equal to PQ minus RS all squared, because they are both equal to PT squared. And thus we've proven what is required. And that's the end of the proof.